Hi, my name is Jose Polito.
My name is Rolga Zori.
My name is Alex Kraus, and this is our rotating forklift for our combined ME154 and ME106 project. The purpose of this project was to redesign the forklift so that more space in warehouses can be dedicated to shelving space rather than forklift maneuvering space. Normally, in a warehouse, a forklift has to rotate its entire body 90 degrees to place an object onto a shelf. With our design, the forklift rotates the bed 90 degrees, which allows more shelving units to be placed in warehouses.
Hi, for our project, I was in charge of designing the mechanism, implementing some of this mechanism, and buying all the hardwares and listing out all of the parts. And also, I was also responsible for the electrical part of it. So in here, as you can see, our mechanism is, and our machine is fully built. We start off with the power supply, which is 24 volts. And as you can see, we connected some switch on it for safety precaution. We also have good wirings with it that for safety precaution as well. And we also interface our motors, our NEMA 23 motors, with 2 drivers. And we also interface it with the power supply and microcontroller. We also printed some of our hardware. As you can see in here, we have our main mechanism that rotates on the Z-axis, and also our lift has a lifting mechanism which housed dual shaft NEMA 23. We also have a bearing underneath, a thrust bearing that basically helps out on the smooth rotation of this mechanism. And we also have some of our other parts that are printed for our parts.
So my part of this project was figuring out what sensors we needed to use for the mechanism and also interfacing them with the Arduino. So we have 2 sensors on this project. We have a load cell that you can see right here, and you can see that it's on this pallet that's above freely hanging in the air, so that when an object is placed on here, it will bend and send a signal to the Arduino in which we can sense the weight that is being lifted by the forklift. It has a HX711 amplifier so that our program can fully read and understand what voltages it's sending to the Arduino. And then the other sensor that we have is a distance sensor located right here. As the forklift lifts up the object into the air, it will sense when there is an open area, meaning there is a shelf, and it will lift up the object into the air, rotate it, and set it down onto the shelving unit.
So I was in charge of fabrication and coding, and when an object is placed on the pallet, a pressure sensor reads the weight. If the weight is too much, a red LED turns on. As you can see, this weight weighs more than 1.5 pounds, so the red LED turns on. Then when I take it off, the green LED should turn on. When I place my phone, the pressure sensor will read its weight, lift it, and then the distance sensor will detect an open shelf and then rotate and place the phone on the shelf. And to illustrate that the mechanism can lift at multiple heights, we're going to change the height of the shelf. So I learned how to read data sheets, how to organize my code, so debugging becomes a lot easier later on, and I kind of learned how to wire stuff up.
What I learned from the project is how important it is to choose the right sensors and motors for whatever job an engineer needs to complete. I also learned about 3D printing as well as fabrication of different parts, and then I learned about power interfacing to the Arduino from an external power source.
I learned more about mechanical design, system design, and mechatronics. I was able to grasp more about the design process from thinking about the purpose of the mechanism into mechanical design, and from mechanical design into manufacturing and fabrication, even down to testing and verification. I also learned how to design using mechanical parts with existing parts such as fasteners, fixtures, and other parts. I also learned how to design circuit schematics and circuit analysis, also including component selections such as motor sizing and reading specs